So students, radial heat transfer by the conduction through the thick cylinder. So thick cylinder concept is there. So before going to the problem, so in for your syllabus, this thick cylinder concept is there already in previous concept. That was the composite wall heat transfer through the conduction through the composite wall. So here the thick cylinder concept is there. They consider one cylinder of length L and inside radius R1 and outside radius is R2 and inside temperature is T1 and outside temperature is T2. So here they will give the direct expression without deriving the expression. They have mentioned the expression directly, that is called as a Q is equals to 2 pi L into K T1 minus T2 divided by 2.3 log of R2 divided by R1. In problem section they will give the problem on this direct expression. You need to substitute this expression and you need to write and substitute the value and get the answer directly. So there is no necessity to derive this expression. In your higher study in engineering, the derivation will come. So next thing is I will take one simple problem that determine the loss of heat transfer per second through a wall of thickness 5 millimeter and total area is 12 meter square when the inside temperature is 25 degree centigrade and outside temperature is 10 degree centigrade. So take a K value is equals to 0.84 watt per meter Kelvin. So what they have given inside, so they have considered one block of inside temperature 25 degree Celsius, outside temperature is 10 Celsius of thickness. Yeah, x is equals to 5 millimeter means and area is equals to 12 meter square. So what they have given, Q you need to find out. Then K value they have given 0.84 watt per meter Kelvin, and x1 is x is equals to 5 millimeter, T1 is equals to 25 degree Celsius, T2 is equals to 10 degree Celsius. So directly we need to write the expression Ka into T1 minus T2 divided by x into T. We have this expression. So T is there, this is the time. But in our problem what they have asked, heat loss per second. Per second means so this T and this T will get cancelled. So K value, what is this K? 0.84 into A is nothing but 12 into T1 minus T2. T1 25 minus 10, 15 degrees Celsius divided by x. We need to convert into 5 into 10 raised to minus 3. 5 into 10 raised to minus 3. So what it means? 0.005 meter, isn't it? So if you calculate this one, the Q will become, see here, 0.84 into 12 into 15 divided by 0.005. So this is 30240 joules. It is in terms of joules. If you want to convert it into kilojoules, what will happen? The decimal will come like this side, 30 point. So this is in terms of kilojoules. This means the Q is nothing but the heat will transfer from this place to this place. It is a 30.24 kilojoules. So this is simple problem. So next one is I will consider a composite wall or a composite material problem. So here I will consider a boiler is made by the iron plates of thickness 12 millimeter thickness, having the surface area 5 meter square. If the temperature of the outer surface is 160 degree and that of inner is 100 degree Celsius, calculate the heat transfer per hour. Second thing is mass of water evaporated per hour. Take K is equals to 84 watt per meter Kelvin and latent heat of water is 100 degrees Celsius and HFG is equals to 2260 kilojoules per kg. So you need to think this problem. You need to read first these problem thoroughly and understood the problem first. What they have given in the data and what we need to find out in the problem. So here just they have given that why the latent heat is given, why this HFG is given. We need to think. Suppose sometimes they will give for your confusing, to make you confusion. So just think what are the necessary for the problem and what they have given and what is our formula. First we need to find out the unknown things. So here second problem, given data you need to write what they have given. First thing is area they have given. First thing is thickness x is equals to 12 millimeter and area what they have given 5 meter square. So 12 millimeter means 0.012 meter. Then if the temperature of the outside surface is 160 degree, see here T1 is equals to 160 degree. You need to convert it into Kelvin. 160 plus 273, how much? 433 Kelvin, capital T1. Next T2, how much they have given? Inner surface 100 degrees Celsius means 100 plus 273 is equals to 373 Kelvin, T2, capital T2. Next what they have given next, K is equals to 84 watt per meter Kelvin. Next per hour, see here the area, the heat transfer per hour. Our formula is per second is there, but we need to convert T is equals to 1 hour. It means 3600 seconds. So first thing they have asked, what is heat transfer? Heat transfer directly Q is equals to Ka into T1 minus T2 into T divided by X. So K 84 into 5 into T1 minus T2. What is this T1 minus T2? 433 minus 373 60 anything 2 divided by 0.12. So solve this one. You will get 84 into 84 into 5 into 60 into 3600 divided by 0.012 7 point, sorry, here I will press engineering 7.56 into 10 raised to 9 joules. So whatever the answer will comes, it is in terms of joule. We need to convert it into kilojoules. 7.56 into 10 raised to 6 kilojoules. So this is the first answer. This is first answer. In second, what they have asked, second thing they have asked that mass of water evaporated per hour. Mass of water they have evaporated per hour. So this is the second thing you need to find out. So in this one they have the formula mass. You need to convert, or you need to find out the mass, total amount of heat transferred divided by heat required to evaporate 1 kilojoules of water or 1 kg of water. So in that one, total amount of heat is transferred, this is done. Then heat required to evaporate 1 kg of water. Heat is required to evaporate 1 kg of water. So already they have given heat required 2260 means 2260. So divided by this one means we will get the this value 3345 kg of steam. Means water evaporated means after evaporating it will become a steam. So this is the problem.